Thank you all for joining us. This actually is a panel discussion on big data. So if you are lost or in the wrong session, now's the time to move. But more importantly, I could not ask for a better setup than this morning's keynotes to look at where ABB is going in our industries, to see how big data, and those of us in the data center industry have long lived under the mantra of, if you can't measure it, you can't monitor it, you can't manage it, you're lost, you've got a problem. So we are looking at big data and what is it, where is it going? And this is a look at both from outside, where big data is going in our industry and where it's taking us and the demand requirements on the data center industry itself as a mission critical infrastructure, but also the utilization of big data inside the data center in managing these massively complex facilities. And what I'd like to first do is have you think for a moment, how does a big data conversation fit into automation and power? And the way I'd like to turn it around is not only what you heard this morning, but I'm going to steal Microsoft's slogan, empowering business. Big data is part of that. It's empowering, and the key word there is not only power, from where we think of as ABB, but also the power to innovate, to design, to deploy, to deliver, and also the ability to use that big data to drive efficiencies, both in performance, energy, or whatever you're looking for. So if I could, I'd like to try and give you just a little bit of an overview of some information that came out recently from the DataCenterDynamics Intelligence Group. These will be the questions we're going to be looking at, by the way, as a startup point. What is big data? Why is it important, especially at a conference like this? How can we enable the data scientists? Is there a march towards open data? We've seen that with open compute. What's the difference between useful data and useless data? Key point. Most people do not talk about big data without first talking about, is it useful or is it useless? Because as we like to say inside the data center space in DCIM, are you about to enter analysis paralysis and be able to do nothing? Mark and I were chatting yesterday about anyone remember the Andromeda Strain movie? Remember that? Where she gets just mesmerized by the red light? Okay, I can tell you, having operated NOCs around the world for Nortel Networks, we would have people who would just turn over and glaze after about 10 minutes of 100 alarms. Okay, so even finding the right people in that world. So useless data and useful data. And also, what are the skill sets needed for the people behind the data? So, big data, what is it, where is it going? Right? If I could, this is from our own internal research. DataCenterDynamics has approximately 35,000 people in 42 locations around the world go to our events. We have the largest data center survey group in the world right now. The surveys are actually done in over 13 languages. Right? So this is what came out from a recent survey, and I'll read it to you guys because otherwise you'll end up with crooked necks. Right? So, what are the key issues? Strategic and asset deployment parameters, scalability. People start talking about big data, they start talking about capacity. Scalability, flexibility. Not just redundancy and reliability, but they start talking about that scalability aspect. Okay? We're all hearing about the cloud. What was it? There was a report that came out yesterday, I believe it was from Gartner. We're looking at the cloud market moving into about, is it 30 billion? Is that right, Jeff? No, 30 billion, I think it was 30 billion with a 29% growth rate. Year on year, which is absolutely stunning. In fact, in China alone, our research saw cloud market growing by 50% just for deep computing purposes. Right? There's a wonderful white paper that came out from Microsoft about 6 weeks ago, I believe it was just after the holidays, that took a look at just deep computing and how Microsoft, through its cloud environment and its software as a service and its platform as a service, has been able to drive some incredible research work around genome splicing, where it's gone from they could do one job a month to now they're doing about 100 a day. Is that right, I believe?
10,000 servers at a time.
10,000, unbelievable. That is big data. That is Microsoft responding to the market around that scalability in the cloud offerings. So deployment around convergence, security and governance, of course, and as I was saying before, the big areas around cost and ROI. All right, a lot of the financial community right now is looking at moving outside because of the requirements of big data. I'll tell you something, in New York City, do you know how much an app dev developer around Hadoop and Python makes? $195,000 a year. $195,000 is now the baseline rate for someone who knows Hadoop, but also knows Python as an application developer. That is stunning, okay? What a difference. Boy, did I make a mistake in my career. Okay? So, management parameters. Okay, what's coming up from top managers from around the world? Mapping to the business, mapping to the brand, getting that information that's coming out. And end-to-end management silos. Big data helps remove because now we're sharing. Remember, if you can't measure and monitor it, you can't manage it, right? Output to analytics. Big data, everyone has to have a big data strategy now, okay? Big data strategies are key in customer service, response, product and service, reliability and development and innovation, right? If you're not listening to your customers, you're going to lose them. Forward capacity planning, too, is absolutely critical in this space, and also the operational system parameters that are very, very key, and I mentioned Hadoop just before, all right? The key point here being that you can see the impacts of big data are on the data center itself, on its operations, on its service capabilities, and across all the way through their systems. There's the perfect example of a data center that collapsed in Virginia approximately 9 months ago. The reason is that it decided it wanted to be a big data player. Its entire data center was actually designed on approximately 5 kilowatts a rack. Once they turned up their high-density computing environment, it was 12 kilowatts a rack. Okay, let's just say that Loudoun County went dark. No, it didn't. Sure, it didn't. Okay, the data center went down and they lost a major customer. Key point here, drivers for data center investment. Focus on capacity, OPEX, network, facility. What's becoming more important? This is what I want you to notice right here. That's big data, okay? Big data is an issue. Look at the growth rate. This is a concern for investment. Where are companies putting their money? The value of big data. But here's the problem. Subsequent research that we did behind this showed they didn't have a plan. Yeah, big data is important, but I haven't got a plan. Okay? That is a key problem. And they are searching for the capabilities and skills around that. Of course, you can see some of the other areas that people are most concerned about. Going greener. These are things that you heard about from ABB. So many of ABB's capabilities actually line up across all of these, not only to improve end of facility life, also to improve redundancy, improve reliability. All the things that you heard this morning from our keynote presenters map up directly with what we're seeing in the market, right? And by the way, this is also very interesting. We haven't increased the footprint of the number of people that we communicate with. We communicate with approximately 98% of the FTSE and approximately 90% of the Fortune 500, right? But you'll notice everything's moving up, except for end of facility life. See that one right there? That's the interesting play in the data center market. Why? I'm just outsourcing to the cloud. What do I care about the end of my life? I'm just outsourcing to the cloud. That's like the new strategic mantra in the industry. Go to the cloud. I was interviewed by, I can't say the name of the newspaper, sorry. I was interviewed for a newspaper that's hopefully going out of business soon. And the gentleman said to me, this is June 2014, Stephen, you're in the data center industry. Your whole industry's gone. There won't be a need for any data centers in the cloud. Hence his newspaper's going out of business. Because if he doesn't know where the cloud is, well. Next, what is the gap between the uptake in in-house and IT technologies and cloud architectures? So the point of this slide is, what are people looking for in terms of where they're moving? And how are the services narrowing? The point here being that in the past, we used to see build of data centers were about 80% enterprise, build my own, 20% colo. Now it's flipped. We're seeing more people move towards colo, outsourcing cloud. So we're seeing a convergence come together and the services are narrowing. The services gap is narrowing, right? So that's the whole purpose of this, is just to show you the growth that's occurring around infrastructure as a service, software as a service, platform as a service, hybrid cloud. Right? By the way, it's very interesting when we talk about cloud and hybrid, about the fact of how different countries use different terminology. You never say the word hybrid in China when you talk about cloud. It's just strange, okay? That type of understanding of a hybrid environment because how the Chinese look at the silos of how they're delivering services and requirements of those services. So here's a wonderful look at that same investment question. Investment in data centers globally will increase to about 200 billion. Okay, so to my newspaper friend who said that the data centers will no longer be built in the cloud, bye-bye. Right? Here it is steadily to growing over 200 billion by 2016. But the growth area is top, co-location and outsourcing. Outsource. Middle, in-house IT, servers, network systems, and in-house facility equipment, where they're spending the money. You can see the largest growth rate is in co-location and outsourcing, although steady growth occurring also around in-house IT. Right? We are seeing many new companies come on the market, push the envelope, and the services around Intel and around Microsoft as examples, helping push the capabilities of your current infrastructure are key. About 3 years ago when, and we heard this morning also, when we had our little economic issue, okay, our recession, the entire data center industry went through a period of sweating their assets. Okay? The former head of a very large global bank called it sweating his ass, because that's what it was. He had to learn how to sweat every bit of what he owned. Every person, every product, every service, every capability, every piece of equipment. And that's when they started looking at where companies like Microsoft and Intel and other players in the market could support. You can't have a power conference without a power slide. Right? So the purpose of this is power consumption will increase slightly. We've seen the value of energy efficiency, of virtualization, of moving towards outsourcing. We've seen the value of everything that ABB has actually done for our market in providing energy efficiency solutions. Better products, better capabilities. We're seeing it across the line, even from our power strips all the way to our switchgear. It's absolutely incredible what's happening, yet growth still continues. And this is part of that tsunami of data, that tsunami. Do you know there was a great interview that was done with he was a film producer, the man who came up with that zombie series. He said that the youth of America is better capable of dealing with the zombie apocalypse than a blackout. The moment you have a blackout, America's children go dumb. Okay? Hurricane Sandy, the #1 complaint of the yuppies in lower Manhattan was not about food and water, it was about getting their iPads charged. I don't know what they were gonna do with them. I mean, take pictures of the blackout? Okay? Don't. But that's the modern American issue. Food, water, I don't care. I can't wait. Right? And that's why power is critical in our lives, in our markets, in our days. Right? So finally, some final notes, and then I'll be finished up. Data centers are at the heart. We heard it this morning. It's the digital industry. It's the digital fortress. It's the digital world that we live in nowadays. Right? And it's going to expand the demand on and on and on and on. Right? The digital content and services are growing. All right. #1 issue, 2 weeks or a week ago. This is past Friday, I think. Netflix launched House of Cards. Latest season. Almost collapsed. Yes, question? No, sorry. Almost collapsed Time Warner's network. But they prepared for it because they saw what had happened. So Time Warner Cable worked hard all summer long preparing for one night. And they did an awesome job. Well done. They prepared power systems, cable infrastructure, brand new switches, brand new routers, everything they could. Sorry, I'm in America, routers. Right? So it's knowing from the big data that they had pulled in, they knew what was happening with their customers and what demand was going to be, so they prepared. Right? Big data represents a new challenge and a new growth driver, not the quantum leap that we think, but more, all right? But the use of it. A number of approaches to big data are out there, but they have to be evaluated. And no disrespect to Amazon, let me tell you something. I know a lot of companies that love and have gone to Hadoop and have gone to Amazon and they think it's the best. I can also tell you a lot of companies that tried to get out. It's like Godfather 3. Every time they have to pull me back in, I'm trying to get back out. Okay? It's hard. Once you make that strategic decision, you are making a decision that you will have to deal with and work with. So know your partners, know your clients when you're working in that space. Scaling and resource aspects need to be factored. And of course, the development of data campuses as a physical and virtual level. Collaborative future. You heard that this morning. That is the future of our industry. If you are not collaborating with Microsoft, with Intel, with all the major players in our market, you have a problem. You have a major problem, and you're about to step in it.
Good morning, everybody, and thanks for coming. So big data used to be the shiny thing in the sky. That was last year, and then IoT came along and that shiny thing dimmed, and now it's pointing at IoT. But in reality, it's the same thing. And we've been living in this world of data exhaust, dirty data exhaust for many years, where the systems that we've got have been spewing out stuff, and we threw it away because we didn't know what to do with it. We actually just discarded most of that data. Partly what's happened now is we're measuring more stuff, and in some cases we're keeping it, and in many cases we're throwing it away again. And so I want to use that as sort of the frame of what's happening with the data. And this is probably one of the most important things, is that today's noise is tomorrow's money. You don't know the value of the data that you've got. This quote, by the way, comes from a book called The Signal and the Noise, which is, if you want to get a basic understanding of big data, it's a great book to read, by Nate Silver, who is the guy who does predictions. He does baseball predictions and took a big data view of baseball, then of US elections, and he's the guy who actually has the highly accurate election predictions. But what he looks at is in the data is you never throw away anything. And how you navigate through the data and how you get knowledge of the data is really where the value is. And the consequence of that is this, which is that data is the new currency. Data actually has value. It has incredible value. And it either has value to you, it has value to your customers or to your partners, to your competitors, to the industry, to the government. There's incredible value in the data, and the trick, the magic trick that happens now is how do you find that value? How do you navigate through it? Who are the people? We alluded earlier to the people who understand the data, who can do things with it. And in some cases, it's not the people who you think. In some cases, it's the people who are really living in the world that we're documenting, living in the world that we're digitizing, who actually understand a lot about the data and sort of what that value is. But in many cases, we see new business models being established around the data and the value of the data, and we'll discuss a little bit more about that. There's also a fundamental change that's happened in the analysis of data, is that we all come from an engineering background. I do, as I'm sure most of the people in the room, where I think about hard cost schemas of data, which are rigid, where you actually get an accurate answer every time. And that's great for statutory reporting, which is you have to know the sales by region, by person. There are accurate numbers that are needed for tax reporting purposes, for example. And there's a one-to-one correlation in the causality between the data and the result. The world of big data, though, is very different. It's a world of correlation. It's a world of 80% correct. And when you look at big data and you analyze that data, if you can actually get an 80% indicator of a pattern and can then make judgment on that pattern, that is where many of the new strides are being made in this area, is really looking at the data and understanding it and looking at the likelihood of something happening. You encounter this every day when you go to Amazon and you buy a book and it says people who bought this book bought that book. And Amazon doesn't have editors anymore, they actually just have reviews by people. And in analyzing that data, they can actually assess that if you like this, people like you, given what we know about what you bought here, as well as your purchase history, not only your books but everything else. Given that history, we can actually assume that there's a probability you'll like this other thing. And so the big mental change for people thinking about data is moving from this world of direct causality into a world of correlation. And for engineers, this is a very difficult task because it's about inaccuracy. And basically, engineers think of things as either being black or white or exact. And this is not about exactness, it's about inexactness. But the value that comes out of it is pretty phenomenal. And the end result of big data is it changes insight. It changes insight dramatically, and this we learned from search. When you go in onto the internet and you do a search, you actually put one or two words and you realize you get thousands of answers back, so you add 2 or 3 or more words to refine your search. And the way to think about insight as it exists today is insight is the best result that you can get in 100 milliseconds, and you go through this iterative cycle of running a query, looking at it, running a finer query, running a finer query, and running a finer query. And so the systems that sit behind this are incredibly complex and sophisticated to be able to deal with large volumes of data and deal with them at an aggregate level and then slowly parse it down until you get to the answer that you want, until you get to the person who's saying something, or the motor that's behaving in a particular way, or a valve that's stuck open. but you start off at the aggregate level and move down. And it's done in a very iterative kind of way with this probabilistic attitude. That's probably, for me, are the biggest changes that's happened as a consequence of big data. Don't throw it away. Your data is incredibly valuable and inaccurate, and basically inexactitude. How you deal with things in a correlation kind of way. Those are the things that I think are changing the industry and changing who we are and what we do. And we'll get to more later. And
So my perspective is certainly different from the hardware side of the data center and putting telemetry in everything that we do from a compute perspective. So we do have a commercial aspect to big data. Intel actually distributed its own Hadoop version a couple of years ago. We determined that going down that software path and selling that on our own, I think we started as a number 6 player, was not the best path for a hardware company. So we punted essentially to Cloudera. Now we endorse Apache Cloudera as a commercial solution. Intel's invested in that organization. So that's one side of the business. The other is, how does big data drive data center expansion? You heard this morning about the increase in capacity, the increase in power utilization, driving efficiency. And here are some numbers around the IoT phenomenon and how that is driving additional data center footprint. We talked about cloud service providers in the opening. Intel segregates its customer base. We have a team that focuses on the top 10 cloud service providers. Last year, that top 10 group grew by 45%, the top 10. We're talking about Baidu, Amazon, Alibaba, etc. And then there's another team that focuses on the next 100. This is a critical growth area that was mentioned before. They are forming they're designing their own hardware. They're coming to us with CPU and chipset parameters that they want us to build for them, and they're big enough to demand that. The other aspect is that we have at the moment about 95% market segment share in the data center. So we build a majority of the IT devices, not just servers, racks, and blades, but it's also networking devices, it's storage devices, it's telemetry around how your IT devices communicate. So these indicators here are just a simple kind of understanding of what people do in their day-to-day lives. They don't realize how the back end, that most of the folks probably in this room, how they're trying to deal with the increased capacity that this is causing. So this continues talking about smart devices, connected tools for technology and automation, medical devices, etc., digital signage and retail. Every aspect of our lives, because of the Moore's Law phenomenon, we continue to put compute capabilities in smaller and smaller form factors. And that's going to continue. We are now in a 10 nanometer cycle of silicon production. And that essentially means that you'll have compute devices that are small enough to put in a button on your shirt. You know, there are incredible ways to continue to build the capabilities of sensors and compute capacity. And what that means is that it's an increase in the amount of data, it's an increase in the amount of telemetry, and the ability to operate that capacity from a data center operator perspective. So that's my perspective, that I'm going to take this. It's great we've got somebody on the operational side who can speak to that. I'm more on the telemetry and the impact of the data center.
Thank you, Jeff. And thank you, Norm. Listening to both of you and talking about data storage, it reminded me of my control system engineering days back in the mid-'80s, and we had we really thought we were really advanced with what was called a Winchester drive. That was 20 megabytes, right? And you know, that was a big deal, right? And we were storing analog signals and some digital signals. You know, valves were on and off and things like that. But then, you know, darn it if that thing didn't get filled up, right? And then we would try to off-store the data because it was valuable, and we needed, like you were saying, we needed to store it. And we put it on these tape drives, and those were, you never knew if your data is really saved or not, right? So that was kind of a questionable, but we've gone way beyond the 20 meg. I got PowerPoints that are 20 megabytes, right? So it's really amazing how we've come along, and there's so many talking about generating data, and there's so many devices out on the facility floor, whether you're running a data center or a chemical facility, oil and gas refinery, or a pharmaceutical plant. There's all these devices, and you see some out there on the floor today. Flow meters, temperature sensors, pressure transmitters, motors, drives. There's a new sensor on a transformer out there that tells you the amount of hydrogen and moisture in the oil, right? So the technology has advanced, like you're saying, Jeff. It's gotten smaller, and it's enabled us to provide new types of sensors that we never had before. But all those sensors are creating more data for us right now. So no longer we just get an analog signal from a temperature device or a pressure device. We can get multitudes of data. I went back and counted that on a VFD, variable frequency drive, there's 99 diagnostics that can be sent up to the control system, in addition to just the regular signals that you can get, right? And then there's flow meters that can send 2 or 3 dozen diagnostics, right? So then you have maybe multiple systems out in the facility, and you got thousands of devices out there, and they're no longer creating the thousands of signals, but multiply that by a dozen, 2 dozen, 3 dozen types of diagnostics that are bubbling up at you. So then you create an environment in your control room that you're overwhelming the operators, and the operators are very, today's operators are typically very knowledgeable about the process. They know what to do when something happens, but they're aging and getting up in the years, and they're starting to retire, so you're losing a lot of that knowledge that's been embedded in these people over the years. So how do you bring in new people? How do you train them? How do you get them to know the process? How do you get them to deal with the alarms, know what to do? And it's similar to a flight deck in an airliner. There's tremendous amount of sensors, a lot more sensors in today's planes than what there used to be back when I was flying a single-engine Cessna, right? When you had a compass, altimeter and airspeed, and you were flying, with a lot less data, and you were triangulating where you were. You didn't have GPS and everything else. So same thing with the automation system. So how do we deal with alarms from all this data? How do we sequence the operations? We want the facilities to be run in a profitable fashion. We want them to run safely. We want them to run reliably. So we have to interface to humans with the process and with the automation system. So today's control rooms are starting to evolve like this. And you can see these collaboration stations that the operator has one keyboard, one mouse, and he has a multitude of monitors there that he can go around, and everything is connected together with aspects into the objects. So the objects are contain multiple parts of data instead of just a single bit of data in today's systems. And then when you have alarming conditions, how do you interact with that? What do you do? What are the sequences involved? So there's new designs out there. This picture here, you can even see when you have alarm condition on the console on the left, the ceiling tiles start to change colors, right? So and I've also seen it where you have there's some lighting on the floor, so that changes color. So you have visual, and you can't hear, but there's new audio alarms as well. So you can have different types of alarms that speak to you in different voices, different tones, like hurry up and deal with this one, or, you know, but there's, you can, it's not only a visual thing, but it's an audio thing that you can incorporate with all that too. So there's a lot of new ways, there's a lot of studies have been done on how to increase the operator effectiveness and using this data that we're generating.